Hi, I'm Łukasz Kużaj, and today I'm going to present you my real case pipeline and possibilities related with it. This is my first time recording a presentation and myself through a webcam, but I'm really excited about this opportunity. Let's get started. Ladies and gentlemen, there are parts of my talk. I would like to begin by sharing a bit about myself. I will introduce assumption to CI/CD concept just to keep the same level of understanding. Let's discuss risks related with the pipeline. Sometimes instead of automating the software development process, a pipeline can actually impede it. Then it's time for my solution. I will introduce you in the architecture, use cases of my pipelines and possible applications. At the end, there will be summary of my talk. I also prepared the set of dedicated dose of humors for this time. I hope you will enjoy memes together with me. My journey in the world of technology and software development has been thrilling and productive. Over the years, I've had the privilege of working on a multitude of projects, including web, desktop, embedded systems with various technology stacks, and through these experiences, I have collected experience working as a tester, developer, test architect, and DevOps. I've gained a deep appreciation of the power of automation. Outside of work, I'm happy husband and father of 3 children. I really love to travel over the world of financial markets and overcome all weaknesses. I'm also a beekeeper. Let's come back to the major topic of today's presentation about pipelines. Continuous integration focuses on the frequent integration and testing of code changes with an emphasis on early error detection. Continuous delivery, on the other hand, extends the CI process by automating the entire release cycle, ensuring that the application is always deployable to different environments, but it may still require manual approval for production deployment. The ultimate goal is to deliver new features or updates to end users quickly and reliably while maintaining the quality and stability of the software. We will focus on CI pipeline in the rest of this talk. So let's go to the further assumptions. There are many valuable outcomes from CI process. Builds can be done and tested without manual action. CI detects issues and bugs early in the development cycle, reducing the costs and effort required to fix them. It leads to higher code quality. Assuming the optimized process, developer receives feedback about his changes in a few instances. CI process is defined and is valid for all changes in the project. It means that every change in the process by the same flow. Let's go to the next one. It is about the risks. When I was talking about the CI process outcomes, there were some assumptions. Now, for each outcome, we can assign a list of dedicated risks. In my projects, there are a few major risks which triggered me to find non-standard solution. We use GitLab pipelines and set of predefined general purpose GitLab runners managed by dedicated infrastructure team and shared across entire company. Projects are led in various operating systems, in various technologies and their versions. Debugging and root cause analysis in complex architecture can be counted in days of work. We started with on-premise systems and prepared it partially for migration to the AWS. Each client has a local database with custom definitions of colors, customers, and so on. We need to be sure that after migration to hybrid infrastructure, all values are available and have the same shape. All outcomes and risks bring us to the main topic of this talk. But now it's time for mem. Let's go to the main topic. It's time to address all points from last two slides. Let's meet Cloud Native Pipeline. I name it Cloud Native because all architecture components are located in AWS Cloud, even GitLab runners. The assumption for the project is that we will design pipeline for system upgrade with database migration so that CI will drive migration and further consistency tests. Let's dive into my solution a little deeper. When we think about the pipeline, there are always doubts about automation and complex process empowered by an arsenal of specialized tools. These tools are the backbone of CI/CD. I put all major tools on the diagram and divided them into sections: build, test, infrastructure, manage software, and monitoring. Infrastructure is served by AWS, managed by Terraform, implementing the infrastructure as a code rules. Docker and Docker Compose for keeping running environment independent on native installation, and Guacamole to install bastion host approach. Build tools are properly used to run front-end, back-end, then GitLab to manage pipeline, Bash and PowerShell for running logic inside pipeline steps. For tests, there is one major engine, which is a robot framework, and other software is just to complete the functionalities near to robot. There are two sections more for managing and monitoring tools. When we know the tools, let's meet the architecture diagram. The entire solution is composed based on AWS components. A virtual private cloud configured with public and private subnets according to AWS best practices to provide own virtual network on AWS. Let's meet the specific components. The AMI snapshot of base system with current production version of application under test. For my case, it was Windows instance with initial configuration of system. GitLab runner machine, which is the EC2 machine created on AMI mentioned in last sentence. Additionally, GitLab runner machine is installed on this machine. Every run of pipeline creates own runner with dedicated GitLab runner. Instances are other computers which are needed to set up environments for tests. Bastion host with Apache service Guacamole, following specific protocols like RDP, SSH to machines being in private subnet. For migration and testing Bastion hosts, it is not needed. It will be used further for debugging. Load balancer automatically distributes incoming traffic across multiple targets. In this case, it will be a bridge between world and private subnet. And the visual regression tracker is a solution for virtual testing and managing the results. It is set on dedicated computer and can be shared across various teams. Then we have a few additional AWS services needed to complete the solution. The first one, CloudWatch, collects and visualizes real-time logs, metrics, and event data. Route 53 connects user requests to internet applications running on AWS using pretty DNS names like Wrobocon.eu. The next one is EC2, compute platform managing volumes, AMI snapshots, machines, load balancers, and so on. IAM manages privileges who or what can access services and resources. And the last one but not least, S3 bucket. It is the standard cloud storage. We will use it for hosting robot results to be available as a service instead of artifacts to download. That's all it means about the infrastructure. How it works? Let's follow the use case. Let's define some user. It may be Wroboconer. He opens a specific URL in his browsers, and load balancer receives his request and connects with Bastion host, because only Bastion host can be reached by load balancer. Bastion host connects and communicates a specific machine. All additional connections inside private subnet are allowed. That's it. I hope it wasn't too daunting. Let's go to the pipeline use cases. I divided operational description into two modes, test and debug. Let's start with test mode. I still describe case for the system upgrade. So pipeline is composed of following jobs: setup, upgrade, test, report, deploy, and teardown. First and last two jobs are executed on general purpose runners having Terraform installed on them. First job creates GitLab runner from AMI with application under test installed. Despite the result, if job passes or fails during the deployed job, new AMIs and created from system after migration and tests. During the teardown, job runner is terminated and no longer available. The middle jobs, upgrade, test, report, are executed on dedicated, dynamically created runners. It means that pipeline contains pure PowerShell commands triggering upgrade, running tests, transfer, and publish tests. It dramatically simplifies the code of pipeline and allows non-experienced team members to read and interact with the CI. What is the outcome of the pipeline? Of course, results, reports. First, XUnit XML report embedded just in GitLab widgets, then pure robot results in HTML, log output in HTML with detailed report, and The last, the detailed report of visual regression tracker. That's all about the testing mode. But sometimes it happens that the pipeline has problems. And what could be wrong? Everything. It was extremely wrong situation. Let's assume that there is something wrong with upgrade itself. We can see that jobs, test and report are skipped, but despite the failure, AMI is created at the deploy job to allow developers debugging. Runner is terminated once AMI creation is done. We have failed pipeline snapshot created at AWS. Now we want to access the machine to find root cause of the issue. In my solution, it is very easy to retrieve build environment. It is just enough to provide pipeline variable version to debug with failed pipeline ID as a value and click Run Pipeline button. It moves us to the second mode of pipeline, debug mode. When user runs the debug mode, it sees the output like you can see now. It is composed of 3 steps: setup, debug, and teardown. Setup and teardown jobs are run on general purpose runners and are used to run EC2 machine from AMI created during failed run of pipeline. This machine is automatically registered in Guacamole, allowing RDP connection from the internet via web browser. When setup is done, machine is available at the Guacamole with failed pipeline ID as a postfix in machine name. Debug job is started. It is time for manual job, which is used to see what happens in work with entire pipeline. During this job, users debugs environment, looking for the root cause. When user finishes his activities, he clicks play button to finish work and trigger destroying machine. This job has defined maximum timeout for 8 hours, so in worst case, machine will be terminated automatically. There are the major information about my solution, proposed and introduced in 2 projects. Let's discuss application of described pipeline with testing and debug mode. They could be used for components tests, where some boundary cases are problematic. At system level tests, where real communication is instead of mocks. Migration tests. It is a very time-consuming kind of testing, and they are repeated many times, especially for on-premises systems, where each system may have a completely different set of data, most used case, and so on. For new installation tests, it only refers to on-premise systems. At our domain, some part of logic is being migrated to the cloud, but due to large number of desktop and embedded applications, some part will always remain as on-premise. Upgrade tests, the same case. Many customers may have different version of software installed. It means that some versions issues may occur. To allow developers to be as close to the customer environment as possible, there are a lot of combination needed. let's go to the summary. In conclusion, cloud-native pipelines represent a transformative approach to software development and deployment. This solution allows development teams to adapt to changing requirements with ease. Described cloud-native pipeline can be executed in parallel so that teams can use it in very large projects with enormous amount of changes. As you have seen, all business logic was located in private subnet. It means that no one can reach machines from the internet. Only Guacamole users can do it via explicitly defined protocols like RDP. Reliability. When something goes wrong, snapshot is created and it is possible to retrieve broken pipeline. It doesn't affect other team members because they have their custom dynamically created GitLab runners. We use AWS services and resources only when pipeline is executed or when debug is in progress. It means we pay only for real usage time. In case of complex systems and permutations of version available and versions to install, presented solution may prepare environment for debugging in a few instances without painful installations, configurations, and other activities related with it. All these aspects have common denominator. They make time to market shorter. It's the essential of modern software development approach. Thank you for joining me in this exploration of cloud-native pipelines. I hope you are as excited as I am about the incredible potential they offer in terms of shorter time to market. If you want to give me a feedback, share your experience, or give me a virtual high five, I invite you to an online session. Thank you.